Hi guys, welcome to Khan series. In this video, we will be discussing about top 25 Python interview questions with their answers. A question: what is the difference between list, trumpet, and set? A list is a mutable and it is ordered and where we can index the slices and we can have duplicate elements in it. But in tuple, we don't have it is immutable and cannot make any changes for it, and there is an order for it, and it has indexes and slices, and we can also it can also accept duplicate values. Set, it is mutable, so you can make any changes, but we cannot have duplicate values, indexes, and slices, or also you cannot have any order in set. The syntaxes may be different. For set, we will have flower brackets, and for list, we have square brackets, and tuples, we will have normal brackets. Next question: explain mutable versus immutable types in Python with examples. Immutable means we can have the various where we can add, modify, and remove elements, and we can make any changes to the objects that are existing. Immutable means you cannot make any changes, like we cannot add, remove, or change. Mutable is slower to access compared to the immutable. Changing mutable objects is easy and efficient, as we discussed before, but immutable it cannot be make any changes. For example, for mutable objects is dictionary, sets, lists. For immutable is strings, bytes, frozen sets, and tuples. What are the Python built-in data types? Python has various data types. If you looking for numbers, we have like int, float, complex. If you are looking for boolean, we can have true and false. If you are looking for sequence, we have string, list, tuple. If you are looking for mapping, we have dictionaries, and if you are looking for sets, we have sets and frozen sets. These are the various types of data types that are inbuilt for Python and which we can use in our application programming. Let's talk about the difference between is and equal to in Python. Equal to is compares the values. The content of the objects are equal or not. Is used to compare the memory or whether the memory of the same or not. Both variable points to the same object or not. So depend upon the requirements, we will be using this in our programming. Next question is, what is Python decorators and where do we use them? Decorators are a powerful feature allows you to modify or enhance the behavior of the function or classes without changing the actual code. A decorator is a function that takes another function as input and returns a new function with additional functionalities. Let's say we have created a function with a name my function, and then we will be using a decorator named yet my wrapper, where we will be calling that decorator inside the function. So when we will be adding it, and we will be adding extra functionalities to the function, and we will be getting the values. Next question: how Python manages memory? Python handles memory management through a combination of automatic mechanisms and internal optimizations. So we have garbage collections. So like automatic memory management, we inside that we have reference counting and garbage collections. Python uses a built-in garbage collector to manage the memory. You don't need to manually allocate or free the memory. The garbage collection handles cyclic references, example object referencing each other after reference counting alone cannot clean up. In reference counting, every object keeps track of how many reference pointers to it. When the counting drops to zero, object is deleted. The object specific memory allocation is one of the memory management technique used in Python. Python uses a private hype space to store objects and data structures. This is managed by Python Memory Manager. Small objects, large objects are handled in this. The memory optimization technique are interning and slots. In interning, Python reuses immutable objects like small integer strings to save the memory, and in slots, it uses underscore slots underscore in classes to reduce memory usage by avoiding dynamic attribute dictionaries. Thus, this is how the memory management is handled in Python. The next question is, what are the namespaces in Python? In Python, a namespace is a container that holds names and maps them to the objects. It helps avoiding naming conflicts by organizing and managing the variables, functions, classes, names in different scopes. There are various types of namespaces. For example, inbuilt namespaces. It contains names like print function, len function, int function, etc. They are automatically available in Python program. And then there is a global namespace. It includes name defined at the top level of the script or module, accessible throughout the module. Local namespace. The next one, namespace, is a local namespace created inside the function and holds the names defined within that function. Exist only during the function execution. Enclosing namespace is the another type of the namespace. It refers to the namespace of outer function in the nested function scenario. These are some of the namespaces in Python. The next question is explain Python with statement and context managers. In Python, with statement is used to wrap the execution of a block or a code within the methods are defined by context manager. It simplifies resource management like opening and closing files, acquiring and releasing logs, and connecting and disconnecting from the database. A context manager is an object that defines the runtime context to establish when executing a with statement. It handles setup and teardown actions using both specific methods like underscore enter, which is used to set up the context and return the resource, and underscore exit underscore self cleans up the context, and even if the exception occurs. This is how the context manager works in a Python. Next question, explain Python Global Interpreter Lock GIL. Python Global Interpreter Lock is a mechanism that prevents multiple native threads from executing Python bytecode at once. It is a well-known limitation of CPython interpreter. So why do we the GIL exist? GIL is used for simplified memory management. Python uses reference counting for garbage collection, and GIL ensures that memory operations like incrementing and decrementing references of the thread safe without requiring complex locks. What is the difference between shallow copy and deep copy? So if you are using a shallow copy, the copies are outside the objects and it has no references regarding the copy of the nested objects. They are shallow copy is partially independent. When nested objects should be shared, we use shallow copy. Deep copy also copies the outer objects, but it has nested objects copies and it is fully independent, and it when fully isolation is needed we will use a deep copy. How do at static method, at class method and instance method differ? The first parameter of an instance method is self, and class method is CLS, and static method has no parameter. Access identifier objects are only available in instance method, not in class method and static method. Access class is available in instant method and class method but not in static method. We can use decorators for class method and static method but not for instance method. If we are updating or read an instance, we can use instance method, or if you are having a factory or utility methods, we can use class method. If you have a utility logic or categorization and helpers, we will use static method. Next question, how do we handle exceptions in Python? We can handle exception in various ways by using try except method. In Python, exception handling is done using try except block, which allows you to gracefully handle errors that occurs during the program execution rather than letting the program crash. So we have this try which wraps the code that may raise exception, and except will catch and handle the specific exception and else run if no exception occurs in the try block. And finally, is used always runs whether an exception occurred or not, used for cleanup. What are Python iterators and generators? In Python iterators, we will be using underscore underscore iter and next underscore next and underscore. In generators, we use yield values. Memory usage is high in iterators because it depends upon the data, but in generators it is low. The creation generators are using a function and yield, but in iterators used to implement iterator methods. It is maintained automatically. Generators are maintained automatically. Iterators are maintained manually. You cannot be reused after generators are not reused after exhaustion, but iterators can be used if reinstated. Generators are easier with conscious syntax, but iterators need more coding to implement. Next question, what is monkey patching in Python? Monkey patching in Python refers to the dynamic modification of a class or a module at runtime. It allows you to change or extend the behavior of the library, classes or objects altering the without altering the original source code. When we will be using monkey patching to fix bugs in third-party libraries and to add logging and debugging features and to override behaviors for testing purposes and to inject custom behavior into existing code. Next question. What is the difference between arcs and k-arcs? Arcs means passing the ab- arbitrary number of arguments. K-arc means passing an arbitrary numbers of argument with keyword. The arcs are tuple, tuple data type and k-arcs are dictionary data types are used. We use arcs when variable positioning arguments. We use k-arcs for variable keyword arguments. Explain how garbage collection in Python works. Python garbage collector is a built-in mechanism that automatically generates memory by reclaiming unused objects, helping prevent memory leaks and freeing developers from manual memory management. Python primarily uses two techniques for garbage collection. Reference One is reference counting and other is cycle detection. In a reference counting, every object in Python has a reference count, the number of the reference pointing to it. When the reference counting drops to 0, the object is immediately destroyed. In cycle detection, reference counting alone cannot handle circular references. For example, two objects referen- referencing each other. The Python garbage collection module uses generically garbage collector to detect and clean up cycles. The generical garbage collectors are divided into three generations: Generation 0, Generation 1, Generation 2. Generation 0 is newly created objects. Generation 1 is objects that survived one garbage collection. Generation 2 is long lived objects. What are meta classes in Python? A meta classes is a class of a class. It defines how classes behaves and a how classes behaves. Just as the classes define how objects behave, meta classes defines how classes themselves are constructed. When you create a class in Python, it is itself an instance of meta class. By default, all classes are instances of the built-in type meta class. You can define a custom meta class to control class creation, modify attributes, enforce coding standards, or inject behavior. Next question. How do you achieve multi-threading and multi-purposing in Python? Multi-threading and multiprocessing are two ways to achieve concurrency, but they work very different under the hood and are suited for different types of tasks. Multi-threading uses the threading module, runs multiple threads within the same process. Threads share the same memory space. They are limited by the global interceptor lock GIL, so only one thread executes Python binary code at a time. It is best for input output bound tasks. Multiprocessing uses the multiple processing module run multiple processes, each with its own Python interceptor and memory space, not affected by GIL allows true parallelism, best for CPU bounded tasks, for example data processing and computing heavy tasks. Explain how memory managed inside Python. There are various ways of memory management in Python like heap memory, reference counting, garbage collector, and garbage collector. Heap memory will store all Python objects. Reference counting will immediately clean up when no reference remains. Garbage collection collector will detect and remove central references. Then generical garbage collector will optimize performance by grouping objects. Thus, the memory is freed and we can use them effectively. Next question. What are descriptors in Python and how do they work? In Python, descriptors are the powerful feature that allows you to customize how attributes access works in classes. They are the foundation of many built-in features like add property, static method, class method, and even ORM field defined in framework like Django. A descriptor is an object that defines one or more of the following methods like underscore get underscore or underscore set underscore or underscore delete underscore. Underscore get underscore is called when the attributor is accessed. Underscore set underscore is called when the attributor is assigned a value. Underscore delete underscore is called when the attribute is deleted. This is how we have descriptors used in Python. It is used for properties, validation, and computer fields programming. How do we implement singleton in Python? In Python, singleton is a design pattern that ensures a class has only one instance throughout the lifetime of a program. So when we code, it will have only one instance when it is executed. And there are several ways to implement a singleton, each with its own single trade-off. So we can use meta classes or dictionaries, decorators or class variables to implement this singleton. Next question. What is the difference between add property and normal method? The syntax of a property is object attribute and for normal method is object method and at property is used to represent computed attributes. Normal method performs actions and calculations. At property is used for encapsulations and read-only accesses, but normal method is used for general behavior. At property can be set only with at properties setter, but normal method we don't need anything. We can just implement it. Explain async and await in Python and how does it differ from threads. Async and await are cooperative multitasking, where the thread is a preemptive multitasking. The execution of a async and await is a single threaded event loop, but the multi threads are executed in threading. Async and await are best for in input and output bound tasks, where the threading is used for CPU bound. The memory usage is high in threads compared to the async and await. The GIL will be affected on multithreading but not on async and await. It is multithreading is easier to use for a simple task where it is complex compared to the async task. Next question, how do you optimize a Python? How do we optimize the performance in Python? Optimizing performance of a Python involves a combination of code level improvements, effective data structures, and system level strategies. So in code levels, we use built-in functions and libraries, and we use to Python's built-in functions like sum, map, filter, sorted are implemented in C and are highly optimized. We can use libraries like NPy, Panda, collections for effective data handling. While choosing the right dataset, use set for fast membership tests and use Binquit from collections for fast append pop for both ends and use default detect or counter for counting and grouping and avoid unnecessary loopings and computings. Use list comprehensions instead of manual loops. Use generators for large data because generators are memory efficient for large data sets. Parallel and concurrency use multi-threading for CPU bound and async and or threading for input output bound. Avoid global variables because it slow down access due to slow resolution. Prefer local variables inside functions. Use effective string operators. Avoid repeated string concurrency with plus in loop. Use string joins for combining string. Use just-in-time compiler in using PyPy instead of C, Python for fast execution in many cases. PyPy includes a just-in-time compiler that can significantly speeds up the Python code and also try to avoid memory leaks. Use weak references for large objects. Monitor memory usage with tools like Transmeloco. These are how we can optimize performance in Python. Thank you for watching our video. Please subscribe to our channel